But I remember writing it for Betty and she was like, I did it, so I don't know if I did it.
Bless you.
I know I wrote it. Just don't.
Valeria. Emily. Thank you. Crystal. Ariana. Yeah.
Perfect.
All right, ladies and gentlemen, here's where we're at. Today we're going to talk about binary and ternary acids. It is the last part of the naming system that you will have. Your test is going to be on Thursday, ladies and gentlemen. Okay? There will be 30 questions on there where you will have to write the formula for 30 names. On 20 of them, you'll have to identify if it is binary or ternary, if it is ionic, covalent, or an acid. Then there will be 30 formulas that you will have to write the names for. And again, 20 of them you will have to identify if they are binary or ternary, ionic, covalent, or an acid. And then there will be about 5 other questions about compounds in general. Things, no, that's fine, thank you. Things like, excuse me, what does it mean to be binary? What's the difference between an ionic and a covalent compound? I'll give you some compounds that say, why can't this compound ever exist? So that is the last, basically, 10 points of the test. Okay, and then there will be some bonus questions on there as well, so there are extra points built in. Today and tomorrow we will concentrate on acids. If we get done a little early tomorrow, that would be fine, because then we would start going through, okay, what are the ways you can look at a formula and you can identify it as ionic, covalent, or an acid? What are the ways you can look at it as name and identify it ionic, covalent, or acid? So that we give you some of those things to help you when you get to your test. Because the questions are going to be random. There are 30 names, and some of them may be acid, some of them may be binary, some of them may be ternary, some of them may be covalent. So you need to be able to look at a name and figure out which system you are using. Okay? Questions? After today, ladies and gentlemen, there's nothing that is in this packet that you should not be able to do. Nothing. But again, how much practice you need depends on how good you are with this stuff. So there's lots of practice in here for you. Lots of practice that can be done. You need to do what you need to do. Okay? And then looking forward just a little bit. There are 4 weeks until the end of the trimester. The 28th of February is the last day of the trimester. Actually, the 27th, because you're not here on the 28th. So that means of the next 4 weeks, 2 of the days you will not be here. You will not be here on the 7th, and you will not be here on the 28th. And 2 of those days are going to be final exams. So in reality, we have 14, 15, 16 days to get everything finished. And we will. Questions? All right. So on last week, Friday, we identified what it means to be an acid. We defined it. Anything that will increase the hydronium ion concentration in water. All acids need to be dissolved in water. What one element is in every acid? Hydrogen. Where's it at? Beginning. What's its charge? What is the charge of hydrogen if it is at the beginning of the compound? +1. +1. Okay? So now we are going to get into the 2 different kinds of acids that there are, ladies and gentlemen. Meaning we are going to talk about binary and we are going to talk about ternary. And they mean the same thing they did with an ionic compound. Binary means there are only 2 elements in the acid. Hey, guess what one of them is? Hydrogen. So it's hydrogen and 1 other element. That's it. And that 1 other element, ladies and gentlemen, needs to be a nonmetal over in this corner over here. Okay? That leaves us 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 different possible binary acids. Actually 14. Which one of those nonmetals cannot be involved in a binary acid? Look in that corner at those nonmetals and tell me which nonmetal cannot be involved with hydrogen in a binary acid. There's only one. I guess you got 15 guesses. What? Nope, not it. 14 guesses. Think about it. Look at what's up in that corner. Which one of those things cannot make an acid?
Oxygen.
What?
Oxygen.
Why? Thank you. Oxygen cannot make hydrogen an acid because it makes it water. It makes it water. So that leaves 14 elements up there, ladies and gentlemen. 14. Okay? So, writing a formula. First of all, we're going back to writing an ionic formula. Meaning, yes, we are back to worrying about charges. But it's not that difficult. Main reason is because hydrogen has what charge? +1. So no matter what, when you do the crisscross method, you are automatically going to be in lowest terms. Automatically, because hydrogen is a +1. Okay? So let's begin with hydrochloric acid. Now, first of all, some acids begin with the word hydro, some do not. Hydro means the acid is binary. Hydro means the acid only contains 2 elements. I would write that somewhere on my periodic table where it is very clear for me. Hydro means that it is a binary acid. And then underneath it I would write no hydro means that it is a ternary acid. If you do not see the word hydro, it means it is a ternary acid. So hydrochloric acid means hydrogen in one other element. I don't know, you take a guess. What other element would be in hydrochloric acid? Chlorine. I mean, it's going to be that simple. Ignore the hydro part to figure out what the other element is. Hydrochloric acid, hydrogen and chlorine put together. Okay? We're going to write the H with the plus to begin. Then we are going to write the nonmetal chlorine with its charge. Maybe. So, hydrogen and chloric. H plus 1, chlorine minus 1. Now, we still need to balance off charges, but what do you get when you take a plus 1 and a minus 1? 0. So you're just going to put these two together. You can do the crisscross method if you want. You really don't have to because you're going to get a 1 and a 1 here. By the way, you'll notice I've dropped the signs. Why? Because we never bring signs down anyway. Okay? So there's your formula, ladies and gentlemen. HCl, AQ. Have to put the AQ after it. You don't, it's wrong. By the way, if you want to make that AQ as a subscript, Control and the comma key on your keyboard will put you typing in subscript mode so that you can put it down under the way it belongs. Now you will see this very shortly, ladies and gentlemen. Hydrogen can only ever be a plus 1. What can the charges of your nonmetal be? What can the charges of the nonmetal be? -1 to -5. And guess what? Whatever this charge is, that's the number that's going to end up by the hydrogen. Because the hydrogen is just going to put a 1 down by whatever it's with. So whatever the charge on the nonmetal is, that is the number that goes right after the hydrogen. That is the charge. That is the way we will balance it out. That is the way we will create a total compound with a charge of 0. But please do not forget to put the AQ in. Questions? Okay. Hydrosulfuric acid. Hydro means binary. Means there's hydrogen in it. Sulfuric means what? Sulfur. Sulfur. Hydrogen and sulfur put together. What's the charge on sulfur? H plus 1 with an S minus 2. What's your formula look like? H2S. Put AQ after it. Do not forget the AQ. Do not forget the AQ. If you do, ladies and gentlemen, it will be wrong. Oh, then if you hit control comma and then it types in bigger letters, that box might have already been in subscript mode. Sorry. Some of the boxes, when I created them, they didn't format correctly. So if you type and it starts out really small, sorry, it's already in subscript mode. You can go to this, you can highlight it and then hit control comma and it'll make it big again. Sorry about that, ladies and gentlemen. Questions? Hydronitric acid. What's in it? What? Hydrogen and nitrogen. Nitrogen has a charge of -3. What does your acid look like in the end? With AQ after it. That's it, ladies and gentlemen. That's it. The same ideas we have been using with ionic compounds. The only difference is the only thing that will be in that first part will be hydrogen. Hydrogen is the only element that will begin the acid. Anyone need more time? We're good? So now, to write a name, you have to figure out, does it have 2 or 3 elements? How do we know if it has 2 or 3 elements, ladies and gentlemen? Capital letters. Capital letters. And one of them is going to be H. Okay, one of them is going to be H. What will be at the end? AQ. So if you're looking at a formula, it begins with H, it ends with AQ, it is an acid. Now, just because it ends with AQ does not make it an acid. It still has to begin with hydrogen. Okay? So, all binary acids begin with hydro and they end with ic acid. By the way, if you look at a name and you can't tell it's an acid, we have major difficulties because every acid has the word acid in it. Seriously. Every acid has the word acid in its name. So if on the test you're looking at names and you come across one and you can't tell if it's ionic, covalent, or an acid, we're in trouble if you can't tell it's an acid because every name has acid in it. Every name. Okay? Now the formula is HClAQ. Hydrogen at the start, AQ at the end means it's an acid. I don't care if there's 1 or 2 elements in here. Okay, means it's an acid if it begins with hydrogen and ends with AQ. So, we've got hydrogen and chlorine. Now, if it were not an acid, you could call it hydrogen chloride. But because it is an acid, we are going to name it as an acid. When we name it as an acid, the name begins with hydro, Hydro, and ends with chlorine, changing its ending to an ic acid. So hydrochlorine becomes hydrochloric acid. Okay? Take off the INE, make it an IC, put the word acid after it. Questions? By the way, no prefixes here. So never going to be trihydro, chloric acid. Never going to be trihydronitric acid. No prefixes here. That is only in the covalent naming system. That is the only place we will use those prefixes. Okay? So H3P. What is P? Phosphorus. So we've got hydro and phosphorus. We need to put them together to make one word. What would that one word be? Hydrophosphoric. And we would end it with acid. Hydrophosphoric acid, ladies and gentlemen. Begins with hydro, ends with ic acid. Again, I will take minor spelling errors in there. Okay? Minor spelling errors, but it has to end with ic acid. And it has to begin with hydro. Anyone need more time? H2S. What do you got? Hydrogen and sulfur, hydrosulfur, hydrosulfuric acid. There you go, ladies and gentlemen. Questions? There they are, all 14. You don't have to do them all. We're going to give you 7 minutes to get as many of them done as you want to do. Then we'll come back together and hopefully you don't all do the same 7. And we'll go through them. That's all of them, ladies and gentlemen. That is every binary acid that you can make. All 14. Go to work. If you have questions, if you need help, ladies and gentlemen, call me over. Give you a phone on my desk. So, thank you.
first one on the furthest left column and the second one on the middle column the same?
First one on the furthest left, hydroiodic. Yes, it is. Sorry. It is. Now I gotta figure out which one I missed. I'll bring it back. Katie is correct. This one, ladies and gentlemen, here is the same as another one. So I'm going to take, that ain't what I want to move. I'm going to get that out of your way until I figure out which one I missed, ladies and gentlemen. Okay, there's the one I was missing, ladies and gentlemen. That ad text was behind there and it was making it so it was hard to see that hydrosalinic acid. Okay, the rules are simple, ladies and gentlemen. If you're handed the marker, you go up and you do one on the board. I don't care who you hand the marker to when you're done, other than me. And the sooner you go up to the board, the sooner you get to pick the one you do. So, let's go. Oh, no. Can you do it right over next to the, right on there? Sorry, just leave that. You're fine. Just do it right next to the formula. Right right next to the name, please.
I think that might be wrong.
Let me double check.
That's wrong.
Oh wait, yeah, I meant to do a different one. Wait.
Yep, be careful. Names, not a lot of difference between some names. Yes. Understand what? Yes, that's right. Okay. So.
Oh, here.
What other names? So, one cancer. Right, you're doing it wrong. One element over here. Let each element get through here.
Oh, man.
Plus one. The formula for chlorine with its charge minus one. By balancing off their charge. Okay? So, and then we put AQ after it so that it's actually an acid and not just a compound.
Yes, I have them.
Boy, we're almost to the end of the row here, and it's gonna be amazing if they actually start over again or if they involve the other half of the row. Because I've had groups who've gotten in wars and two people have handed it back and forth until they did all of them themselves.
Let's come put that here.
Now the question is, does Ethan give it right back to the start of the row or not?
Probably.
Or does he involve other people? A marker made it to the other side of the room, ladies and gentlemen. I am impressed. Doesn't always work that way. Come on, Saphira, I'll help you. Bring your periodic table, please, or I got one for you, either way. Whichever one you prefer. Okay, which one do you want to do? Hydrophosphoric? Okay, well, what do sulfuric? Okay. So what do all acids begin with? Look at every one of them here. What do we write down first? Okay, so put an H down. Let's do this. I'm going to make life a little bit easier for you. Okay, so sulfuric, what element do you think that comes from on your periodic table? Okay, so write the symbol for that. Okay, now what charge is sulfur? Okay, so where would that 2 go, minus 2 go in the formula when you do the crisscross method? Okay, so put it there. Okay, now the only thing left to do is what every other one of these acids did. There you go. You are done. No, thank you. Thank you for taking a chance and coming up and doing this. So whoever gets that marker that Anna's handing out, you get to pick the very last person to come up and do the last one. No, I'm sorry. I'm sorry, you don't.
The heck is going on?
I'm sorry. Yasmin will. There's only 3 left, I think, unless I'm missing one, right? Okay, you get to pick the last person. Hydrobromic up here, Maya, is the last one, I think, if I'm not missing something. Start looking through, ladies and gentlemen. I did not look at them all. So start looking through and seeing if you agree with all of the ones that are up there. Right? It is possible that someone could have made a mistake. Hydroiodic, are we good with high? Yes? Hydrobromic, are we good with HBr? Hydrofluoric, are we good with HF? Hydroboronic, are we good with H5B? Not a lot of eye contact right now. Are we good with this? Yeah. What?
I'm good with it.
Well, that isn't what you had the first time, though, right? And
Well,
be careful.
No, I did have it. I just put it on the wrong
You just
one.
put it on the wrong one? Okay.
Yeah.
So again, be careful because some of these, the names can be a little bit tricky. Boronic and bromic, very close together. Okay? Carbonic and chloric could even get mixed up. We good with hydrocarbonic? H4C? We good with hydrosiliconic? H4S. We good with hydrosulfuric? H2S. All of these are AQ, by the way. We good with hydrophosphoric? H3P. Hydrotelluric? H2TE. Hydrosalinic? H2SE. Hydroarsenic? H3AS. Hydrochloric? HCl. Hydroastatinic? HAT. Guess I never noticed that one before. So, you know, if these 2 elements combine to form what every baseball player needs in the outfield, that'd be a great bonus question on a test. And then, ladies and gentlemen, H3N for hydronitric. Are we good? Now, I do not guarantee you that all of these acids exist. But I guarantee you we can name every one of these. And you know what? To be honest, maybe hydrosiliconic is hydrosalicylic. I'm not 100% sure. Again, minor spelling errors I will accept on your quiz, on your test. Okay? Questions? All right. So, since that takes care of every binary acid, ladies and gentlemen, let's move on quickly to ternary acids. Now, to be a ternary acid, what must be involved in the compound? 3 or more elements. What's the only way to get 3 elements involved in this compound? What was the only way to have a ternary ionic compound? Yeah, but where do we have a list of them? No, we do not. But we do on the back of your sheet. It has to involve a polyatomic ion. So, just like a ternary ionic compound has to involve a polyatomic an ion, a polyatomic has to be involved in a ternary acid. Now, one of them cannot be. Which one? Which one cannot be involved on the back in a ternary acid? Why? Yeah, and we already got a positive charge in the compound with the hydrogen. So you'll never find one with ammonium in it, ladies and gentlemen. Okay? At least not that we will talk about in this class. So, with that in mind, ladies and gentlemen, that means that we are left with the other polyatomics on the back. And I got good news for you. There are 3 others that cannot be in an acid. What's actually 4 others? What's one of them for sure? That you cannot put with hydrogen to make an acid. Look at your list. Turn your periodic tables over. Look at the back. Which one can you not put with hydrogen to make an acid? Because what will you make? You put H with hydroxide, you got H2O. That's better known as water, ladies and gentlemen. Now, there are 3 others on the back that cannot be made into acids. Take a guess at which 3 they are. Let's see how good your deductive reasoning is here, ladies and gentlemen. What? Good. That's 1. 2 more. Nope, that one can. There's only 2 more. Ferric cyanide. What's the last one?
Ferrocyanide.
So any of the ones that end in IDE cannot be made into acids, ladies and gentlemen. So now we're down to just the ones that end in ATE. ATE. So we're more limited on these, ladies and gentlemen. We're more limited on these. All right. Writing the name of a ternary acids. Ternary acids do not begin with hydro. They do not begin with hydro. That is for binary acids. So, all ternary acids are named based entirely on the polyatomic ion. They are named entirely based on the polyatomic ion. So here is the formula of a ternary acid. What polyatomic ion is involved? Chlorate. So we are going to name this based entirely on the polyatomic ion. No hydro. Okay? Now, here's the rules, ladies and gentlemen. If your polyatomic ends in ATE, it becomes an ic acid. If your polyatomic ends in ITE, it becomes an OUS acid. So, this is chlorate. That becomes what? Chloric acid. Not hydrochloric, just chloric acid. So ClO3 is chlorate. This becomes chloric acid, ladies and gentlemen. This becomes chloric acid. Now, what do you notice about the formula? Tell me something you notice about that formula that easily identifies it as an acid. AQ, but more importantly, hydrogen's at the front. The AQ is a good sign, but remember, things can be aqueous without being an acid. Hydrogen in the front, AQ at the end. Now, how many different elements here total in this compound? You're going to name it based off of the polyatomic on the back of your sheet there. And your polyatomic has to end in ATE or ITE. Has to end in ATE, has to end in ITE. Okay? HNO3. What?
Nitric acid.
Okay. So NO3 is what?
Nitric.
Nitrate. So nitrate becomes nitric acid. Nitrate becomes nitric acid. By the way, what if the ending was NO2? Well, the polyatomic would change its name to nitrite. The acid would change its name to nitrous acid. What if it was just NO? Hyponitrous acid. There's the entire naming system for acids. If it's ternary and it ends in ITE, you are going to simply make it an OUS acid. Now, it might have hypo in front. More than likely not. What would happen if this was NO5? HNO5. I'm sorry, HNO4. My bad. No wonder why you're looking at me like I'm crazy. HNO4. Per nitric acid, because it would come from per nitrate. Per nitrate. Don't forget to sign back in. Otherwise your pass will stay going forever. Here's the HNO2. You just told me NO2 was what? Nitrite. Nitrite becomes nitrous acid. That is why we eliminated the ones with IDE ending. Why? We couldn't do this with them, right? Couldn't do this with them. So ATE becomes an IC acid. ITE becomes an OUS acid. If there is something in front of the polyatomic per or hypo, it stays. But ITE always becomes an OUS acid. ATE always becomes an IC acid. There's a phrase that somebody once told me, ladies and gentlemen, that goes like this. A person ate an acid and it tastes icky. Ate goes with IC. Again, you may want to write that down somewhere on your periodic table where you have that hydro and no hydro. If it ends in an ITE, it's going to be an OUS acid. If it ends in an ATE, it's going to be an IC acid. And by the way, acid is in the name again. Acid is in the name again. It's not nitrous. It's nitrous acid. It's not nitric. It's nitric acid. Now what happens if we put hydronitric acid? Now we go back to being a binary acid. Two elements, hydrogen and nitrogen. So you can have hydronitric, you can have nitric, you can have nitrous. You could even have pernitric and hyponitrous. That's it. That's all the possibilities for acid. And again, some of them probably don't exist, but we can still name them with this system. We can still name them with this system. H2SO5. What is SO5, Ariana? Okay, thank you. I just wanted to know what SO5 was, but you took it even a step further, and that's fine. Persulfate, which becomes persulfuric acid. Okay? Again, named on that polyatomic, ladies and gentlemen. Named on that polyatomic. Persulfuric acid. Questions? Yes, no, maybe so. H2CO.
Hydrocarbonous acid.
Wow, that was quick. You sure?
Yes.
What CO?
CO would be
Well.
Oh, don't back down
I
now.
forgot what the name of that was, but I know that it lost to.
Okay, so what's the name of CO3 when it loses 2 oxygens?
Nickel carbonate.
Hypocarbonite, absolutely, which becomes
Hydrocarbons.
good. Hypocarbonous acid. You got it. Don't back down. You're doing good. You're doing good. We can name any change to any polyatomic that we can do on the back with this naming system because they're all either going to end in ATE or they're going to end in ITE. And if they end in ITE, we're going to make them an OUS acid. If they end in ATE, we're going to make them an IC acid. Okay? All right, so acetic acid. First of all, what do you notice not at the beginning? No hydro, right? Now, that means there's no hydrogen involved, correct? No, hydrogen is still the first element in your compound. But the fact that there is not the word hydro means it is not what? It's not binary. So acetic acid would come from what polyatomic? What polyatomic would give us acetic acid? What? Acetate. So acetic would come from acetate. What's the formula for acetate? C2H3O2. What's its charge? So what are we going to put with it? That's a negative polyatomic. What's our positive part? Hydrogen. So we're going to put hydrogen with it. H in that C2H3O2. What do we get? HC2H3O2. Do not put your H's together here. You won't recognize it as an acid if we make it C2H4O2. Don't do that. Don't do that. And that is written in lowest terms, ladies and gentlemen. You cannot change that because we are not allowed to change that polyatomic group. Questions? Can I move on? Or are we still writing things down? Sulfuric acid. What does sulfuric acid come from? Binary or ternary? Okay, so what are ternary acids named by? What is their name based on? Okay, so in sulfuric acid, if it's an ic acid, it came from what polyatomic? Came from sulfate. Sulfuric came from sulfate. What's the formula for sulfate? SO4. What do we put with it? Hydrogen. By the way, whatever charge is up here is still the number that's going to be by the hydrogen. And because hydrogen is a 1, we're never going to put anything in parentheses, ladies and gentlemen. There's no reason to. There's no reason to. The only thing we're ever going to put down by the nonmetal is a 1. No reason to change it ever. H2SO4AQ. Sulfuric acid. What would hydrosulfuric acid look like? H2S with an AQ after it. Sulfur is a -2, H2S. Nitrous acid. By the way, OUS has to come from a polyatomic because all of our binary acids end in what? They end in ic acid. OUS has to be a polyatomic, okay? So what polyatomic? What? Tell me the last three letters, just because I'm not sure if I'm hearing you correct. No, not 8. 8 would be nitric acid. OUS comes from nitrite. Thank you. Nitrite. OUS acids come from ite polyatomics. Nitrous comes from nitrite. Nitrite is NO2 and a -1. I'm sorry, nitrous or nitrite is an NO2 -1. What do we put with it to balance it? Hydrogen. So H plus 1, NO2 minus 1 gives us HNO2. Aqueous. That's it. Questions? Hyponitrous. Where does hyponitrous come from? Hyponitrite. ITEs. OUS acids still come from ITE. Hyponitrous comes from hyponitrite. What is the formula for hyponitrite? And what? NO. NO, still a -1. Still put it with hydrogen. HNO, aqueous. Questions? Again, there is nothing in this packet that you can now not do. There is a couple pages in here on acids. If you haven't completed the part on covalent or on binary ionic or ternary ionic, my suggestion is you get some practice time in, ladies and gentlemen. Make some compounds. If you have questions, please let me know. I will be more than happy to come over and assist you. But the one thing you need to understand is in 3 days, you need to perform on a unit test. So, go to work, ladies and gentlemen. Go to work, go to work, go to work.